So here we go. According to my notes, which I hope are correct, we are ready for problem 3B. We had right at the end of the period last time talked about how to find a determinant of a 3 by 3, or of a 2 by 2, I mean, a little 2 by 2 determinant. So these vertical bars mean we're going to do the determinant. Does anybody remember, or can you look at the problem above it that we did the other day? Can you remember how to do this? No? Well, it's really easy. Just got to remember it. So we take 2 times 7. So 2 times 7. Look at my hands. 2 times 7. We take 3 times -1. And we subtract those. So 2 times 7, 14, minus -3. So the answer to that problem is 17. 14 minus -3.
We're on 7.1, right?
No, we're actually on 7.2. We're on 7.2, number 3A. The page is numbered 45. All right, so now the next one is exactly the same kind of problem. So can you do this one? Do it exactly the same way. Anybody want to venture a guess? What do you think the answer is to this?
Is it 5?
I don't think so, but I see what you did. It's -3, that's -1 times 3, 2 times 4, but you subtract them, Gabe. So it's -3 minus 8. So the answer would actually be -11. In the determinant process, it's a subtraction. All right, so that's our last example of these, kids. Everybody get this process down. It's these two times each other, these two times each other, and then you subtract them. So -3 minus 8. -3 minus 8. All right, does anybody have a question about the 2 by 2s? In order to do a determinant, in order to do this vertical bar thing, the matrix has to be square. So 2 by 2s, we talked about that process. Everybody clear on it? One more time. Multiply these two, and subtract those answers. So -3 minus 8, or 14 minus -3. Now, the next one is a 3 by 3. This is easy, but again, it's a process that you have to keep straight. So here we go. 1, 2, 0, 0, -1, 3, 1, -2, 1. All right. Okay. To do this problem, it's still freezing in this room, so I'll put my sweatshirt back on. All right, to do this problem, we're going to take the first 2 columns and recopy them over here. So 1, 0, 1, and 2, -1, -2. Remember, the columns go up and down. So I recopy this one, the first column, recopy it right there. And then the second column, recopy it right there. So far, so good. Now, look where my finger is. I'm going to start right here. And I'm going to multiply these 3 numbers together. I'm going to multiply 1, negative 1, and 1. This diagonal, I'm multiplying them, and I'm going to get negative 1 when I multiply those three numbers together. Now I'm going to multiply these three numbers together. Multiply, that's 6. And then I'm going to multiply these three together, and that's 0. So I always start right here with the very first number, and I multiply. And then I multiply, and then I multiply. Now, those answers that you got when you did all that multiplication, total them up. We want the grand total. So this is a negative 1, a 6, and a 0. When I add all those up, I get 5. Now you're half done. Because now you're going to turn around and do the same thing the other way. So we start here, always start here at the very beginning. First number. And do. Now, do the same thing this way. So multiply these, 0. Remember, anytime you multiply by 0, you're going to get 0. Multiply these, negative 6. And multiply these, 0. So I got a 0, a negative 6, and a 0. Total them up. Oh, that's easy. That's negative 6. So all of these, the down ones where I multiplied down, they total up to 5. The up ones where I multiplied up, they totaled negative 6. Your answer, to get your answer, you subtract those two numbers. So 5 minus negative 6. 5 minus negative 6. So the answer to the problem is 11. There are some steps there to remember. It's easy math, but you have to keep track of those steps. Does anybody have a question about where a number came from? There. Okay, well, let's try the next one then. It's exactly the same thing. All right, so I think I copied it right. Okay, who can tell me what the first step is? What do I need to do first?
Write down those first two columns.
Mm-hmm. So this is the first column right here. Write it down. And then write the second one. Right next to the problem. All right, who can tell me the second step? What do I do next? Well, I start multiplying. And you always start multiplying right here at the beginning. So we're going to multiply these three numbers together. Okay, that's a little bit bigger. Let's see, that is 36. And now we multiply these together. That's 0. And then we multiply these together. That's 1, so that's 37. My total is 37. Now we do the same thing, other direction. Okay, so here we go. This one gives me negative 8. Negative 2 times 4 times 1. Remember, you're multiplying. And then you're multiplying, but you got a 0, so it's going to be a 0. And then you're multiplying, and I got a 6. So for that total, I got negative 2. I had negative 8, 0, and 6. So I total all those up, and I get negative 2. Does anybody remember what I do now to get my final answer? What do I do with those two numbers?
You subtract them?
I do subtract them. So it's 37 minus negative 2. Well, 37 minus negative 2 is 39. So the answer, the final answer, after all that work, the final answer is going to be 39. All right, there's one more. Why don't you see if you can get it started? There's one more of these to practice. Remember, before you can get started, you have to recopy those first two columns. Make sure you copy them exactly as they are. So you got to include the negatives if they have negatives in them. I got 4 as my grand total for my down multiplications. Are there any thumbs up on that? Did anybody get 4? Good. Okay, great. Let's see. Watch all these negatives now on the ups. I got 20 for the ups. Thumbs up? Awesome. So then my final answer is going to be negative 16. 4 minus 20, negative 16. Did anybody get that by yourself? Awesome. Good work. All right. Easy, easy math. But we're starting to get a lot of processes here we got to keep straight. And we're going to get one more in this section. One more process. So any question about this before I erase it and we move on to the next section? Anybody not get negative 16 and want to talk about it? Okay. All right, so here we go. We're going to now find the inverse. So that's what this notation means. This means the inverse of A. So we're going to find the inverse of matrix A. It is a two-step process. Step 1. Find the determinant. Now that's what we did the very first thing. We're going to find the determinant of this matrix. So the determinant is those vertical bars. Those vertical bars are the determinant. Okay? Now, who remembers how to find that? What's the answer to that? Anybody remember? We did it earlier today. Okay.
Isn't it like 3?
No, but I know exactly what you did. You made the same mistake Gabe did earlier. It's 1 times 5 and negative 1 times 2, and then those are subtracted. So it's 5 minus negative 2. So the determinant is actually 7. Remember, your determinant is down minus up. Down minus up. So it's 7. All right, that's step 1. So this finding the inverse is a 2-step process. The first step is find the determinant. Got it, 7. The second step is build a new matrix. It has a name, it's called the adjoint, but you don't need to worry about that. We're just going to call it a new matrix. And when we build the new matrix, this is the way we build it. Again, guys, very, very easy, but you have to keep all this straight. Jaden, thank you. All right, so here we go. To build the new matrix, look where my fingers are. These two numbers, right here where my fingers are pointing, right here, they switch places. So 5 goes here and 1 goes here. These two numbers right here where my fingers are literally switch. So the 5 comes up here and the 1 comes down here. Whatever they are, they switch places. These other two numbers become the opposite. So in other words, that's a positive 2, it becomes a negative 2. You don't move it. You don't move it. It stays right where it's at, but it becomes the opposite of what it was. So this is a positive, it becomes a negative. This is a negative, it becomes a positive. So whatever these two numbers are, they stay in their spot, but they become the opposite of what they were. So we have done both steps now. We have found the determinant, it was 7, and we've built our new matrix. Your answer will simply be all of these numbers right here, this new matrix, divided by the 7. So in other words, 5 over 7, negative 2 over 7, 1 over 7, and 1 over 7. That's your answer. So you simply take this new matrix that you built by switching and doing the opposite, and you divide each one of those numbers by your determinant value, which in this case is 7. That's the answer to the question right here. This is the answer. You ready to try another one of those? We're going to do another one, and we're going to do exactly the same steps. So let's see what we got this time. So this time our matrix is 1, negative 3, 0, 4. All right, so we're going to find the determinant first. Go ahead and see if you can figure that out. Can you figure that out? Anybody got an answer? What do you think the determinant of that matrix is?
4.
Yes! Perfect, beautiful. It's 1 times 4 and 0 times negative 3, so that's 4 and 0, and you subtract them. So the determinant is 4. 4 minus 0, always down, minus up. Down, minus up. Perfect, 4. Now just hang on to that for a second. Now we're going to build our new matrix. Now remember how we do that. Look where my fingers are, and those switch. So you're going to put the 4 here and the 1 here. These numbers switch. Now, what happens to these other two? Remember, what do we do with them? we make them the opposite. So 0 is just 0. You don't have to do anything to it. But that 3 there is negative, so it's going to become positive. Remember, these two here, where I'm pointing now, these two, they become the opposite. So 0 is 0, but a negative 3 becomes a positive 3. And then what do we do to get our final answer? Put these two together. How do they go together?
Divide by the determinant.
Exactly. So we take each of these guys right here, each of those, and put them over the determinant. So that first one's going to be 4 over 4, 3 over 4, 0 over 4, and 1 over 4. Each of these numbers over 4. Now, if it can simplify, you should simplify it. So maybe you did that as you went. I did not. So I'm going to have 1 3/4, 0 1/4. And that is my final answer. We always want to reduce our fractions if it's possible to do so. Okay? All right, now we've got the next one, same thing. We're going to do exactly the same set of steps. All right, so I know the first thing I need to do is find the determinant. Would you all find the determinant of problem C for me? All right, so everybody's going to find the determinant. Remember, it's downs minus ups. Downs minus ups. Anybody want to venture an answer?
10.
Okay, I heard a couple of different things. I think the answer is 10 because it's 6 minus negative 4. My downs, 2 times 3 is 6. My ups are negative 4. So 6 minus negative 4 gives me a determinant of 10. Guys, we got to get that right. We're going to use that in another kind of problem too. So we have to get that right. Does everybody understand where the 10 came from? Downs minus ups. All right, now we're going to build a new matrix. So go back to the original. Take these two right here and switch them. And take these two right here and make them opposite. So the 1 stays in this spot, but it becomes positive. And the 4 stays in this spot, but it becomes negative. To get my final answer then, I am going to take each of the numbers in the new matrix and divide it by 10. If things reduce, I need to reduce them. So 3/10 does not reduce, and 1/10 does not reduce. But negative 4/10 is negative 2/5, and 2/10 is 1/5. So this would be my final answer. Okay? All right, there's one more of those. tell me what you get for your determinant. Nice. Thank you.
Thank you.
I'll send those in later and let you know what he says about the quiz.
Okay. Thank you so much.
All right, anybody get a determinant value?
0.
Oh yeah, very good. I hope everybody got 0. The downs are 8 and the ups are 8. So when I subtract, I get 0. Now, I want you to think about something for a minute. I'm going to go out on a limb here and say that there is no inverse. Can somebody tell me why that is? Why am I just not even doing that next part and just saying there's no inverse?
Because you divide that new matrix by the inverse, so it'll just all be like, you can't do it undefined.
Exactly. Very good, Gabe.
So can I come in on Wednesday to take quiz 4?
At the same time?
Same time.
I think so. What is Wednesday? Day 5? Yeah, that'd be fine.
Okay. Thank you.
Okay. All right, so we have no inverse because, as Gabe said, when the determinant 0, whatever that new matrix is, I'm going to be dividing everything by 0, and that is not allowed. So if your determinant is 0, you have no inverse. Does anyone have a question about that? That makes sense to everyone? Okay, all right. Now we're gonna do some work on our calculator, but before we do that, we're gonna go to the next page that says use Cramer's rule to solve. And then we'll go to our calculators. We're gonna use Cramer's rule to solve. All right, everybody find the page that says that? Use Cramer's rule to solve. All right, so here we go. If you look at these problems, they look exactly like the substitution and elimination problems. Would you agree with me? They look just like the substitution and elimination. So you could, if you were walking down the street and found one of these, you could use substitution or elimination, absolutely, to get the right answer. But today we're going to talk about a new method called Cramer's rule. And the first time through, you're going to say, oh my gosh, Mrs. Ward, why would I ever do it this way? But after you've done it a couple times, you will figure out that in many problems, this is the fastest, easiest way to do the problem. Here's how it works. It's very, very simple. First thing I want you to do is find the determinant of the coefficients. Now, by coefficients, I mean the numbers hooked to the x's and the y's. So 2, 3, 3, -4. So find the determinant of the coefficients. So determinant, that's the straight line thing. Coefficients, 2, 3, 3, -4. They must be in order. Make sure you have everything lined up, x's and y's all lined up, and then you're going to find that determinant. Okay? So shout it out when you think you've got it. What is the determinant of those coefficients?
Is it -14?
You're so close.
Wait. -17.
There we go. It's -8 minus 9, -17. Remember, it's downs minus ups. So you multiply down, and you multiply up, and you subtract. So it's -8 minus 9. Okay, we got to get that right, guys, or we will not get the right answer. Okay? Perfect. Now, here comes it's easy, but it's a little bit tricky. When we are solving this system, you are looking for the ordered pair where they cross, right? Like 1, 3 or something like that. in this problem, the answers are going to be fractions, and the denominator of the fraction is that negative 17. So your x is going to be something over negative 17, and your y is going to be something over negative 17. Okay? Now, to find the somethings, it's really easy. To find the x something, this is the numerator for x. These are fractions. The numerator for x. Take these numbers, which you haven't used yet, the constants, the 1 and the 2, and pretend that you can cut them out and paste them on top of your x numbers. Remember in the original problem, the 2 and the 3 belonged to x. When you are solving for x numerator, you take the constants and paste them in the x column. So you're going to have the 1 and the 2 in the x column, and then the 3 and the negative 4 in the y column. So I am looking for the numerator, remember, ordered pair, x comma y. I'm looking for the numerator of my x. I know the denominator is negative 17 for both of them. I'm looking for the numerator for x. So I take my constants, these numbers over here, and I paste them on top of the x numbers, the 2 and the 3. So then I have that determinant. To do y, I'm going to do exactly the same thing, only instead of pasting the 1 and the 2 in the x spot, since I'm solving for y numerator, I'm going to take the 1 and the 2 and paste them in the y spot. So that'll look like 2, 3, 1, 2. All right, let's take a pause there and see who has a question. Okay, well, now we just have to evaluate these and then we'll be done with the problem. So remember to evaluate, it's multiply the downs, multiply the ups, and subtract them. So negative 4 minus 6. That's negative 10. That is my x numerator. This one, 2 times 2 minus 3 times 1, that's just 1. That's my y numerator. So my final answer is 10/17, negative 1/17. The negatives cancel on the x's, and you can put that negative in the top or the bottom on the y, it doesn't matter. That's the answer to the question. Now, that took forever because I was talking and repeating myself and going slow and all that. But I want you to think about something, kids. This is the answer to the problem, all right? It doesn't matter how you do it. That's the answer you're going to get. So if you would have done, let's say, elimination, you would have gotten x equals 10/17. What do you do then if you're doing elimination or substitution? After you get the first answer, what do you have to do to get the second part of it?
Plug it in.
Exactly. Kids, what a nightmare. You'd have to plug in 10/17 and do all of the arithmetic with common denominators and adding and subtracting fractions. What a mess. This is a horrible answer. But did it matter to me? Did I have to do anything with the fractions? Nope. Nope. Cramer's rule is a beautiful thing because it alleviates all of the messiness that usually pops in when we do substitution and elimination. All right, let's try the next one. We're going to do exactly the same thing. with the next set of equations. So who remembers what we do first? What's always step one? We find our denominator. And our denominator is going to be the determinant of the coefficients. So here are my x's, here are my y's. So I have 1 and 1 and 2 and negative 1. So 1 and 1 and 2 and negative 1. Those are my coefficients, and that's what I start with. What is that determinant? Well, down minus up, negative 3. Now that means that my final answer, my ordered pair, my x and my y, are both going to be fractions, and their denominator is negative 3. This is going to be my x, and this is going to be my y, and they're both fractions over negative 3. Down minus up. Okay, so to find the x now, these are the numerators. These aren't the answers, they're the numerators. To do the x, we take the 7 and the 8 and plug them in right here under my hand. This is where the 7 and the 8 go if I'm doing x. So I'll have a 7 and an 8, and then a 1 and a negative 1. And then for y, same thing, only the 7 and the 8 go here. So I have 1, 2, and 7 and 8. Notice I'm not switching any order or anything like that. I'm physically cutting this out and pasting it. So I still have 1, 2 in the first column, and now 7, 8 in the second column when I'm doing my y. All right, so here we go. What's my x numerator determinant? Can anyone tell me?
Negative 15.
Yes, we're getting it. Yay, we're getting it. It's negative 7 minus 8, negative 15. Perfect, perfect, perfect. And that's what goes in the x numerator. All right, somebody else tell me, what's my y determinant, my y numerator determinant?
Negative 6.
Yes, we are awesome. 8 minus 14, negative 6. Downs minus ups. Now, always, always simplify if possible. This one does simplify. It really is a nice one. X is just 5, and y is just 2. That is the answer that you would get no matter how you did the problem. That is where these two lines cross each other at the point 5, 2. All right. Next. See if you can get this next one started. Remember, the first thing you do when you're doing Cramer's rule is you find the determinant of the coefficients. So that would be the 3, negative 4, 1, and 2. So you find that determinant. All right, somebody new, somebody who hasn't talked yet today. All right, anybody? What's the determinant? Yes. 6 minus negative 4. 6 minus negative 4. That is 10. So our answer is going to be something over 10, comma, something over 10. The 10, the coefficients, that determinant becomes the denominator of your answer. To find the x numerator, we're going to cut out the 9 and the 2, cut it out, paste it on. So we're going to have 9 and 2 and negative 4 and 2. And then for y, same thing, cut it out, paste it on the y's. So 3, 1, 9, 2. Zaniel, what is this x numerator? What is that determinant going to be?
Do you multiply it?
You multiply the 9 and the 2, so you get
So you
18.
get 18.
Mm-hmm. And then you multiply the 2.
You get negative 8.
Uh-huh. And then we subtract those. So it's 18 minus negative 8.
Right, and you add that, right?
Yep. So that'll be a 26.
Got it.
And then that 26, that was my x, so that goes in the numerator of my x answer. Remember, the 10 is the denominator, the original 10 that I found from the coefficients. But that was my x work, so that gives me 26 for the numerator. All right? Kennedy Harden, what about this one?
Is it 3?
Be careful, it's actually negative 3 because it's 6 minus 9. Does that make sense, Kennedy?
Yeah, it does.
Okay. So that's my numerator here, negative 3. Now, sometimes you can simplify, sometimes you can't. This time we can. 26 over 10 is actually 13 over 5. And then negative 3/10 does not reduce. So this would be the final answer that goes into your answer blank. All right, there's one more. I'd like you to see how far you can get with it. So remember, there's 3 determinants. 3 of these things you have to find. There's the coefficient one, and then there's the ones for x and y. So look at the examples that we've done and see how far you can get with this problem. Okay, does anybody, have you gotten the first determinant, the denominator? Have you done the coefficients yet? Do you have an answer there, anybody? Not yet?
23.
I think 23 is right. Remember, we multiply 2 times 1. We multiply negative 3 times 7. And then we subtract those. It's always downs minus ups. So 2 minus negative 21. So that's how we got 23. And those are that is the denominator of both x and y. Perfect. Okay. If you're struggling, I want you to look up here now and see the setup. I'm now ready for my x numerator. So when I find my x numerator, I go back to my original determinant. The first column was the x numbers and the second column is the y numbers. And I'm going to replace those with the 1 and the 8, the constants over here. So I cut that out and paste it on top of the x. So that's how I got 1871. Then for y, I do the same thing, only I paste them on top of y. So that's how I got 2, negative 3, 1, 8. Does anybody have a question about that setup? Okay. Anybody have an x numerator yet? Anybody get a determinant for x? Princess? You got one?
Negative 55. I got negative 55.
Negative 55 is right because it's 1 minus 56. 1 minus 56. So that numerator is negative 55. Courtney, do you have one for y yet, for the y numerator? Courtney, you there? Courtney, can you just say something, please?
Yeah,
Oh, good. Okay, you got an answer, or are you still working on it?
still working on it.
Okay. Farrell, what about you? You got an answer? Oh, Farrell. Uh-oh, Farrell. All right, JP, you got an answer?
19.
He got 19. I haven't even done it yet. I think he's right. 16 minus negative 3. Very good. It is 19. That's a 19. So 16, 2 times 8, minus negative 3. Perfect. And nothing reduces there, so that's just it. That's the answer to the question. When we get around to having a test over this stuff, guys, the 3 of the questions are going to be solve using substitution, solve using elimination, solve using Cramer's rule. And the problems are all going to look exactly the same. They're going to look like this. But depending on what the directions are, you'll work on each one in a little bit different way. anybody have a question about that answer, where any of those numbers came from? Farrell, where were you? I was calling on you and you weren't responding.
I used the bathroom.
Oh, okay. All right, so here, the very last thing we're gonna do, and we're almost done, so we're not gonna get very far. I need everybody to have a calculator tomorrow, because everything we do tomorrow, at least in the beginning, is gonna be on the calculator. So, or next time we have class, so make sure you have yours. If you have your calculator with you, would you get it out? And I want everybody to locate a really important button that we're going to be using, okay? Obviously, this little unit we're doing is about matrices. So we're going to be using the matrix button on our calculator. So the matrix button is a second, I'm going to have to do a second, and it's in the first column of buttons here. Do you see the word matrix written there? In my calculator, it's in blue. Everybody find it? So we're going to press second matrix, and we're going to get a whole menu of stuff to do. And we're going to work on that next time we have class. So be sure that you have a calculator. It's going to have to be a grapher. And make sure you know where the matrix button is on that calculator, because that's what we're going to do. Anybody have any questions about that? Ah, so good to be back. Everybody's thrilled starting your week off great with math class. All right, I'll see you, I don't know, a couple of days, I guess. Have a great day.
Thank you.
Bye-bye.
Mrs. Ford,
Yes.
I used my phone today 'cause